Okay, so this is one of the common problems that you'll see here for word problems and applications of rational functions. So this is what they call a combined work or rate problem. You can see that Shelley can paint a fence in 8 hours, Karen can do it in 4 hours. How long will it take them to do the job together? This could be painting a fence, painting a house, just doing anything that people need to do together. So if we think about it this way, Shelley has a rate of 1/8. We know she's got to combine that with Karen's 1/4 to get it accomplished in 1/t hours. The 1 represents the actual job, so the painting of the fence. It's a little weird, but that's the painting of the fence. So they have one fence and they need to figure out how long it takes them to do that together. Now, we're going to treat this as rationals. We can just simply treat this as fractions and add those two together and then solve for t. But if we're going to treat this as a rational function, we're going to find an LCD between these three, and that is 8t. Now, if we multiply everything by 8t to eliminate the fractions, we have 8t over 8 plus 8t over 4. That's going to equal 8t over t. And now we can just simply cancel 8 over 8. 8 over 4 becomes 2. And then we got t over t, and that just becomes 8. So if we kind of combine everything, we have t plus 2t equals 8. Now if we combine those two terms, we have 3t equals 8. And now we're going to divide everything by 3. And so we get t, so how long it takes them to accomplish it together, is approximately 2.67 hours. You can read the Mr. Lon that made 58 out of 82 attempted free throws before school this morning. If he has a running total for the week and his goal is to make 90% of his free throws, how many does he need to make in a row to achieve this goal? So, as you can see, I'm a poor free throw shooter because 58 over 82 is approximately 63%. I shoot better than Shaquille O'Neal, but worse than Dirk Nowitzki. So what I want to do is, because I need to make the same amount, I have to take the same shots and make the same, or make consecutively. That means I have to make X in a row to increase that to a percentage of 90 over 100. So this problem, again, if we treat this with rationals, we're going to, sorry for the sticky notes or keys. So we're going to simply cross multiply. So we got 58 plus X times 100, and that's going to equal 82 plus X times 90. Now we do some simplifying at this point in time because we can cancel out one of the zeros from 90 and 100. So if we distribute, now we're going to distribute 10 and 9. That's going to be 580 plus 10x equals, do a quick calculation of 82 times 9. 82 times 9 equals 738 plus 9x. Now we're just going to simply solve this now. So minus 580 minus 580. So it's 10x equals 158 plus 9x. You can already see that I'm going to have to make a lot of free throws in a row. I don't know if I have it in me to make 158 in a row, which is what our answer is going to be. Now, if you want to do a quick check, you can say, okay, 58 plus 158 over 82 plus 158, that's 216 over 82 plus 158 equals 240. And if you do that math, that equals 90%. So that's how many I need to make in a row to raise my free throw average to 90%. I got it in me, so maybe one day I'll actually try that. Okay, this next problem is very famous because these are the famous DRT problems that you see show up on SAT, ACT, Algebra 2, Algebra 1. Because we are talking about rational functions, usually in a DRT problem, something is the same. It can either be the distance or the time. The distance is if you're doing systems of equations. Time is if you're doing a rational equation or solving rational equations. It's because if you were to solve that for t, you get d over r. Okay, and remember, r is the rate at which it's done. Okay, those of you guys taking physics know that this r is actually speed. So if Jason's riding his bike for 50 miles at a speed of x, and then it increases his speed by 10 miles per hour for the next 100 miles, that's our situation. So you notice that we have two legs, right? First leg is 50 miles at x miles per hour, and then the second leg is 100 miles at x plus 10 miles per hour. Let's make sure we put our units in. That's just the physics teacher and me. So we know that this trip is going to take 10 hours. Okay, and then we want to know how fast was he going. So what is x, right? And what is x plus 10, the speeds for those two trips. Okay, so if we know that the total trip took 10 hours, and we know that from our equation that we solved earlier, that he does 50 miles in x miles per hour, that's going to give us the first leg. Now we have the second leg. He's going to do 100 miles in x plus 10 miles per hour. So there's our rational function that we're going, or rational equation that we're going to solve. So we start off with the LCD, which is just simply x times x plus 10. Okay, and now we're going to multiply everything by that to eliminate the denominator. So we have 10 times x plus 10 equals 50 times our common denominator. That's going to be over x plus, slide the screen over a little bit, undo, redo. I'm going to slide the screen over a little bit to give some space. Beauty of technology. And then we have 100 times x plus 10 over x plus 10 for that part of the trip. All right, now we can just start canceling. Nothing cancels here, but if we kind of do some expanding, we end up with 10x squared plus 100x equals, now from our first part, right, we have an x on the top, we have an x on the bottom, which means we can cancel those. So from here we have 50x plus 500 plus, and now this part of the equation, we've got an x plus 10 on the bottom, x plus 10 up top. So we can cancel those, leaving us just with 100x. Okay, so now it just becomes, let's see if there's stuff that we can cancel. Remember the classic, if you see the same thing added on or subtracted on both sides, you can just cancel them. Note that I can divide everything by 10, so that 10 goes away. This becomes a 5, that becomes 50. So after doing some simplifying, we got x squared equals 5x plus 50. And now because this is a quadratic, we're going to want to put get our right side here equal to 0. Okay, so cancel, cancel. That becomes 0. So we have x squared minus 5x minus 50. And now we have quadratic factoring. So what are the factors of 50 that subtract to 5? And remember, you're going to get the middle sign. So x minus 10 times x plus 5. Multiplication rule. If a times b equals 0, that means either a is 0 or b is 0. And if we do a quick solving, we get x equals 10, x equals negative 5. And now because this x is miles per hour, okay, we're going to cancel that out because we're always looking for the positive value. Now, this happens to be one of our legs. So the first leg, he's going to be going 10 miles per hour. But the question asks us for both legs. So that means we're going to go 10 miles per hour plus 10 miles per hour. And that's going to give us 20 miles per hour. So there are your two answers. So for the first leg, he goes 10 miles per hour. For the second leg, he goes 20 miles per hour. And if you want to, we can do a quick check of that. So that means he's going 50 over 10 miles per hour. So the first leg takes him 5 hours. Then he does 100 over 20. Second leg, he does it also in 5 hours. 5 plus 5 is 10 hours. And we know that's how long it took him.